Bismillahirrahmanirrahim. Assalamu alaikum. This is our 27th lecture of Advanced Electromagnetic Field and Waves, and in this lecture we are going to discuss a problem related to uh, cutoff frequency for waveguides. Okay, so here an example you have is a common air-filled rectangular waveguide. Means you have a rectangular waveguide, has interior dimensions. Dimensions are given like a equals to 0.9 inches and b equals to 0.4 inches. In centimeters it's 2.29 centimeter a, and for b is 1.02 centimeter. So these are basically called as the expand guide. So what you have to find, you have to find the cutoff frequency for the lowest order for TM mode. Okay, keep remember for TM mode the lowest order is 1 1, means n value is 1 and m value is 1. But for the case of TE mode the lowest order is 1 0. Okay, in TM mode 1001 not applicable. In TE mode 01 and 10 is applicable, but TE00 is not applicable. So the cutoff frequency formula, you know, that is equals to C by 2 under the root m by a whole square plus n by a whole square, because you have to find the lowest order non-trivial TM mode. So the lowest order is, as I mentioned, TM11. So the n value is 1 and m value is 1. And see, the waveguide is in air, and you know that in air the speed of light is 3 multiplied 10 raised per 8. You have to these values in centimeters, so 2.29 into 10 raised per minus 2 and 1.02 into 10 is per minus 2. By putting the values, you will get your cutoff frequency, and the cutoff frequency is 16.09 gigahertz. Okay, so this is basically the cutoff frequency. Now, in second part, let's move on. What you have to find, you can see here at a source frequency that is twice of the cutoff frequency. Means if an external source frequency is coming and it's twice of the cutoff frequency, means now cutoff frequency is less, but the incoming frequency is twice of the cutoff frequency. So you have to determine the propagation constant. Propagation constant means k, kz. Kz is basically the propagation constant what you have to find for this mode. Also obtain the wavelength. You also have to find wavelength lambda, and you have to find the phase velocity Vp, and you have to find the intrinsic wave impedance, because the incoming wave has a frequency twice of the cutoff frequency. So the incoming wave frequency becomes 2fc, and this is the frequency of incoming wave. As the frequency of incoming wave is greater than the cutoff frequency, so you can say that yes, your wave will propagate. Okay, so if your wave is propagate, so you can easily find the aspects which we required. Like first of all, we need the wave propagation, and wave propagation formula, we know that kz, for the case of wave propagate, if wave propagate means that the incoming frequency is greater, so you can write the formula as under the root k square minus kc square, where k is the wave vector of incoming and kc is the uh, wave vector of the cutoff frequency. To find wave propagation, you need the wave vector k and you need the wave vector of cutoff frequency. So first of all, we have to find k and then we have to find kc. How we can find k? So you know that the wave number k is basically the wave number or wave vector. So the formula of k is basically omega by c, and omega is basically the angular frequency, and you know that omega is basically equals to 2 pi f. Okay, so 2 pi f is basically the incoming frequency, and incoming frequency, you know that it's the twice of the frequency. So as we already find it, this is 32.18 gigahertz. Okay, so here you have to put the value 32 giga means 10 to the power 9, 2 pi divided by c. So this is how you get your wave number, and the unit of wave number is radian per meter. Okay, now you need the wave number of cutoff frequency, so same formula, but what you have to do, 2 pi, instead of, because you are finding now for cutoff, so you have to only put the value of cutoff. So we know that the cutoff frequency value is 16, which we already find here, but the incoming is twice of the, therefore that when we for using for only wave vector, then we use that value of f for incoming, and but when we are solving for wave number for cutoff frequency, then we use fc, and fc value is 16.20 into 10 to the power 9 gigahertz. Okay, so this is your value, 337 radian per meter you got. Now you have to put this value and this value in your this formula of the wave propagation. So wave propagation is the under root of the k square wave vector square minus wave vector of the cutoff frequency square. So you will divide these minus this square, take under root, you will get your answer, and your answer is 584 radian per meter. Understood? Okay, now move on towards our next part, in which you have to find the wavelength. And the formula of wavelength, you also know that in term of wave vector, that k is equals to 2 pi by lambda. But if you find lambda, so lambda becomes equals to 2 pi by k. Okay, 2 pi by k. So k, which k? This k, this k, or this k? You have to use the wave propagation k. Not only wave vector, not only the cutoff wave number, you have to use the wave propagation k. The wave propagation k you already find here. So 2 pi by kz. Kz is basically wave propagation. 2 pi by this, the value. So you will get it 10.76 millimeter. So two things you successfully find. Now move on towards the fourth point requirement. And the fourth requirement is you have to find the phase velocity. The formula is quite simple. The phase velocity Vp can be defined as omega by k. Okay, where again this omega is the frequency. You know that omega is basically the angular frequency, which is equal to 2 pi f. Okay, and you have to use general omega here for incoming, and incoming f, and f you know that it is the twice of the cutoff. We already find twice of the cutoff, and that value is 32.1 into 10 to the power 9. Okay, so the formula of phase velocity is omega by k. Okay, similar formula you can see from here. This is formula if you move c upside, so c becomes omega by k. Say c basically the speed, so this is also the speed or velocity you can say. So omega is 2 pi f, putting the values, and again below you have to put the wave propagation, which is this, and but the unit of phase velocity is meter per second because it's a velocity. 346 into 10 is per 6 meter per second. But if you convert into kilometer per second, so you will only left with 346 kilometer per second. Understood? So this is how you can find the phase velocity. Now our last requirement is you have to find the impedance. Impedance formula is, you know, that z equals to eta under the root 1 minus fc divided by f ka whole square. Okay, whereas eta is the journal value, okay, in air, and this is the constant, and the constant is equals to 337 ohms, and 1 minus fc by f. Fc is basically the value of the cutoff frequency, which is 16, and f is the twice of the this, which is 32.18. So taking square 1 minus this, you will get your answer, multiply by 377, you will get 326 omega. This is real value, this is real value, this is real, this is real. Why we are getting real values? Because the cutoff frequency is greater than the the incoming source has frequency greater than the cutoff frequency. Okay, that's why all we got values are real. But you can see in the third part, repeat the same scenario for if f equals to half of the cutoff frequency. Okay, so you have to repeat the same values. You have to find the wave propagation, you have to find wavelength, you have to find impedance, and you have to find phase velocity. By considering your incoming source has frequency half of the cutoff frequency. So if the frequency of incoming source is less than the frequency of the cutoff frequency of that waveguide, your wave will not propagate, because in that scenario you can see cutoff frequency is greater than f. So this is below cutoff. So your wave will not propagate. So this factor is smaller than 0. So you will not propagate, your wave will not propagate. Your kz expression is imaginary. There is iota sign there. You are no longer getting the real parts. Now you are getting the imaginary parts, because the incoming frequency is less than the cutoff frequency. In journal, by just putting the value, you can check 16.09 is the cutoff frequency, and if this is half, so it becomes, you can see, 8.04. You can see this is the frequency of incoming and this is the cutoff frequency. So incoming frequency is low than the cutoff frequency. That's why your no wave will not propagate. If your wave is not propagate, then you can say your k is equals to 0. So if your kz is 0, so your wavelength is undefined, because in formula of wavelength there is 2 pi by kz. When you're putting the value of kz 0, so you are getting infinity value. Your wavelength is infinity, undefined, and you're also getting phase velocity undefined. And if your frequency is low than the cutoff frequency, there is no impedance also, because you are getting the imaginary parts, no real parts. So that's all for this question of this lecture number 27 of advanced electromagnetic field and waves. In coming videos, we will upload more interesting questions for this course. Till then, take care and Allah Hafiz.